All right. So, welcome to Biology and Health. I believe there's a couple of things. So make sure you read your assignment sheet. I believe you're going to be doing some presentations on Monday, so make sure to go over that. Shouldn't be a big deal. Easy for me to say. I'm not the one doing them. All right, so let's start off. We're going to be talking about chemical and cellular basis of life. So what normally comes up when we talk about this is, why do we study chemistry in a biology class? And that's because chemistry and biology are intertwined. So they're not distinct. And you'll notice in some of the videos where they start talking about physics. So all these disciplines in science don't exist on their own. They overlap. So it's good to know, because I mean, in biology, we're literally going to be talking about the building blocks of life, which is chemistry. So we're gonna dive into chemistry, and this will probably be the more difficult component of the class. And once we kind of go over the chemistry portion of class, it should really ease up a fair amount. So this is difficult, but just keep moving forward, do your best, ask questions, try to absorb what you can. We'll get through this. So matter. This is what we talk about a lot in science. So it takes up space, it has weight. So solids, liquids, and gases. And so even gases, even though we can like throw our hand through some fog, it still has weight. It's not as much as, say, like a hammer, but it still has weight. And so then there's an atom, and the atom is the smallest stable unit of matter, and that's important. You'll notice in some of the videos where they talk about like both how our concept of an atom is wrong, and how there are smaller components of an atom, but these are the stable forms. So there's going to be different models we look at because there's different understanding of what an atom is, and it's still developing, and just different models. So we'll go through. And so different types of atoms form the different types of elements. So there's 92 natural occurring elements. There's some extra ones that were actually created, and they form all matter, both living and non-living. Humans are made up of 26 elements, and each type of element is composed of chemically identical atoms. Remember, the atom is the smallest particle of an element. So you may or may not have seen this before, but this is how we organize the elements. It's called a periodic table of elements, and they're organized in categories and classes, and this is a highly organized chart where everything has been put in its spot for a specific reason. So you can see like how there's non-metals, there's alkaline earth metals, there's rare earth metals. And so, to be honest, I probably don't get past the first 10 before I start going, what is that? So I'm not asking you to memorize, but it's always good to know where to go look for it and find it. And to do a lot of the work that we're going to do, it's going to be handy to have this there because, as we'll talk, a lot of the answers are right on this table. So this is just a breakdown of those major elements that make us up. We're largely comprised of oxygen, and then carbon and hydrogen. And then we got a bunch of little things in us, sulfur, chlorine, magnesium, and then really, really small, but iron, manganese, zinc, copper. So we're made up of chemicals and atoms, and that's one of the reasons why we go over this in a biology class. So this is one model of what an atom looks like. All right, so atoms are composed of subatomic particles, and we call them protons. Proton has a plus charge, and it has a mass equal to 1. A neutron has no charge, and it has a mass equal to 1. An electron has a charge, but it almost has 0 mass. And so, wink, wink, nudge, nudge, hint, hint. That's information to help you out with some homework you're going to encounter. But let's take a look in this model as well. So we call this the nucleus, the center of the atom. And that's where the neutrons and protons are. So neutrons and protons are in the center of the atom. And electrons, depending on the model, so in this model, they form like in these little rings that are outside. You'll hear in some of the videos how like electrons are all over the place. But this is easy for us to conceptualize. So neutrons and protons are in the nucleus, and electrons are outside. And electrons almost have no mass. They do have mass, but it's very, very small. So again, the nucleus is the center of the atom, and that's where the protons and neutrons are. Outside of the nucleus, you have the electron cloud. So that's what we imagine with the rings. And we can add and remove to create ions. And so ions are, we'll talk about those in a little bit, are a form of each atom. It's a charged atom because normally atoms are electrically neutral. So this will show up again, wink, wink, hint, hint, nudge, nudge on a homework assignment. So if you want to take a quick screenshot, awesome, and get a start on things. But this is just the information we just covered. And so now it's in video form. You can go back, take a look and fill that out. So atomic weight is the number, comes from the protons and the neutrons, because remember, electrons really don't have that much weight. So we're adding up the protons and the neutrons to establish how much something weighs, and we call that atomic weight, because even though we're talking about weight, though it's so small. So that's how we keep track of that. Now, oxygen, as an example, has 8 protons and 8 neutrons. So the atomic weight is 16, 8 plus 8. We're adding up, because each one is 1, 8, we have 8 protons plus 8 neutrons, it equals 16. So that's the atomic weight of oxygen. Handy little thing to know as you move forward in this study to help you out with some of the homework. So we have isotopes, and an isotope is an atom that has the same number of protons but a different number of neutrons. So, we were saying how oxygen, the atomic weight is 16, but we do have oxygen 17 and O18. It's the same element, just with a different weight. It's in a different state. So how many protons would be in O16? And we just discussed that it's 8. O17, how many neutrons? And it's always going to have the same amount of neutrons. So that means it's the difference between the neutrons. And so unstable isotopes are radioactive and emit energy. And so a lot of times in history, and I believe that one of the video talks about that, people who've discovered these elements have not have died prematurely, shall we say. So the atomic number is the number of protons. So each element has a unique atomic number, and that's the number when we look at the periodic table. So will the number of protons in an atom also determine how many electrons there are? Well, if an atom has 9 protons, how many electrons will it have? And so that's how we're going to address how we're going to address what we talked about now. So the electrons are found in electron shells. And each shell holds a limited number of electrons. So the first shell holds 2, the second shell holds 8, and the third shell holds 8. It's what we call the octet rule. So other than the first shell, and in that model, that's the first circle, you have 2 and then 8 and 8. The lower shells fill first, and that outermost shell is called a valence. A full valence shell is a stable atom. An unstable atom will react with others to form stable compounds or molecules. So it'll connect with other atoms to create a whole new thing. So will an unstable atom have a full valence shell? No, because a stable atom has a full valence shell. Unstable atom does not until it reacts with some other element, some other atom to form stability by becoming a compound or a molecule. So this chart will show you the approximate atomic weights, numbers, and symbols. I want you to take another screenshot of this. This will show up again, where you'll have to solve how many protons each element has, or at least for hydrogen, carbon, and sodium. How many protons, neutrons, and how many electrons are in the first, second, and third shell. So I'll give you a chance to take a look at that. So a molecule is when 2 or more atoms chemically combined. So they fill each other's valence shells and then they create almost a whole new thing. Whereas a compound is when 2 or more atoms of different elements chemically combined in a defined proportion. So molecular formulas have the elements present and the number of each atom present in the molecule. So H2. So we have 2 hydrogen atoms. C6H12O6 would have 6 carbon, 12 hydrogen, 6 oxygen. H2O, so water, is 2 hydrogen atoms with a oxygen atom. So again, take a screenshot of this. At some point, you'll be turning these questions in your answers. So just again, to kind of give you a head start on things and know what's coming up. So there's this thing called ground state, all right? And it has some rules to it. So the first rule is that the orbitals of the lowest energy are filled first according to the order. So remember, like that first shell fills up first with 2. And only 2 electrons can occupy an orbital. They must be of opposite spin. So electrons actually spin. There's a lot of movement going on. And if 2 or more empty orbitals of equal energy are available, 1 electron occupies each with the spin parallel until all orbitals are half full. So, for instance, hydrogen has only 1 electron which occupies the lowest energy orbital. So hydrogen has a 1s ground state configuration. Carbon has 6 electrons in the ground state electron configuration, 1s2, 2s2, 2p2. So there's a superscript, and that's what we call like the bigger number, to represent the number of electrons in a particular orbit. We're going to go through that. It talks about that in the book that you have the link to. So it's going to take a lot of practice and watching those videos to kind of get a hang of that. So again, take a picture of this. This will be a future homework question. So you will have to examine the ground state of a particular molecule. And when we get together, remind me to talk to you about potential tutors for this, because this is not exactly the easiest thing. So we do have available to you some tutors through an organization called Learn to Be Foundation. So go ahead and bring that up. So just a quick review. How many electrons does potassium have? 19. calcium has 20, and aluminum has 13. So again, take a picture of this. This will be a future homework question. So give the ground state electron configuration. Again, I'm going to suggest asking me about that tutor. It'll just help you out so much, and myself as well. So almost towards the end, but I did want to talk to you because this is too will turn into part of your homework. Okay, so we saw that one model where it was this concentric circles, and so we can see that down at the bottom with the chlorine atom. This is normally how we document an atom, or at least for me, that's how has always been in the case. But like you heard in the videos, like really, this model doesn't represent what an atom actually looks like. Now, another way that we can do a model of a atom is what's called the tetrahedral geometry model. So in this one, we're just documenting it a little way, different way. So we're going to use solid lines to indicate bonds in the plane of the page. All right, so like just like this chlorine one. And again, it goes over this, I think, fairly quickly in your book. We're going to use this heavy wedge line to indicate a bond coming out of the page, and then a dashed line to show a bond receding or going away from us. So this here is an example of so C is carbon, H is hydrogen, chlorine, 3 chlorine molecules. We have our hydrogen, they bond to, and these bonds are like when we form a molecule where they start sharing. And then it has the 3 chlorine coming out. What I'm going to want you to do, and haven't quite determined at what date, but better to be started. I would say at least get that first slide that I showed you, have that done by next week, just to kind of just pacing, okay? Just so that things don't wait till the end. You'll draw a tetrahedral model of this lovely C2H6, which is ethane. So a lot of times we diagram it like this, or even over here, or like that. And so remember the bonds of the plane on the page, and look it up. This is a total Google it type situation. Solid lines are the bonds of the plane on the page. Heavy wedge lines are bonds coming out of the page toward the viewer. And dashed lines are a bond receding back from the page away from the viewer. So just let me jump back to that first one. Just like I mentioned, I would strongly suggest you get a start on this particular one. So again, just talking about the locations. So protons are in the nucleus. That's what we mean by location. The charge. Remember, 2 of them have a charge. One of them does not. The mass. So that's completely, so there's our location. There's our charge. There's our mass. So just getting that down, and can transfer from one atom to another. So that one's either going to be in your book, you do reading. So that'll be important. And then answer this question as well on a piece of paper. And as this as well. And so I would get a start on this. This is doable. And then we'll move on to some of the harder stuff. And like I said, it's going to be hard up front, and then it'll really level out. But for now, we're going to get a lot of this information down and straightened away. So I will see you in class.